Hi everyone, and welcome to Fact Science, the channel where we explore the most fascinating and mind-blowing concepts in the universe. Today, we are diving into the mysterious world of wormholes. Get ready to have your mind blown wide open as we uncover 15 fun facts about these theoretical tunnels through space and time. From their connection to Einstein's theory of general relativity to their potential for time travel, wormholes have captured the imaginations of scientists and science fiction enthusiasts alike. We'll explore what they are, how they might work, and the implications they hold for our understanding of the cosmos. So buckle up and get ready for an exciting journey as we unravel the mysteries of wormholes together. Let's get started. Let's get.
Imagine a shortcut through the fabric of space and time, a cosmic tunnel connecting two distant points in the universe. That's the basic idea behind a wormhole. Wormholes are like bridges or tunnels that could potentially allow us to travel vast distances in a much shorter amount of time than it would take using conventional methods. Think of it like folding a piece of paper in half and poking a hole through it. The paper represents space-time and the hole represents the wormhole, providing a shortcut between two distant points. While still purely theoretical, the concept of wormholes arises from the complex equations of Einstein's theory of general relativity, which we'll delve into more deeply in just a bit.
To understand wormholes, we need to first wrap our heads around Einstein's theory of general relativity. This groundbreaking theory, published in 1915, revolutionized our understanding of gravity. Einstein proposed that gravity is not a force, but rather a curvature in the fabric of spacetime caused by massive objects. Imagine a bowling ball placed on a trampoline. It creates a dip or curvature in the fabric. Now, apply this concept on a cosmic scale. Stars, planets, and even light itself are influenced by the curvature of spacetime caused by massive objects like black holes. In the 1930s, Einstein and his colleague Nathan Rosen further explored these ideas and realized that the equations of general relativity allowed for the possibility of bridges connecting different points in space-time. These bridges are what we now call wormholes.
We just learned that wormholes get their name from how they bend space and time, like a shortcut for a worm through an apple. But did you know they have another name? They're also called Einstein-Rosen bridges. These amazing theoretical objects are named after, you guessed it, Albert Einstein and his colleague, Nathan Rosen. In the 1930s, they were studying the complex equations of Einstein's theory of general relativity and made an amazing discovery. Their calculations suggested that wormholes could exist as solutions to these equations. Basically, the math showed that these shortcuts through space and time weren't just a crazy idea, they might actually be possible. So next time you hear Einstein-Rosen bridge, remember you're talking about the same mind-bending wormholes we've been exploring. Pretty cool, right?
Imagine traveling to a distant star system thousands of light years away. Even with incredibly advanced technology, it would take us, well, thousands of years to get there. That's where wormholes come in. Remember how they connect two distant points in space-time? Well, some scientists believe that wormholes could act like cosmic shortcuts, allowing us to travel vast distances in a blink of an eye. Think of it like folding a piece of paper in half and poking a hole through it. Instead of traveling the entire length of the paper, you could instantly jump from one side to the other through the hole. Of course, this is all theoretical, but the possibility of faster-than-light travel is one of the most exciting things about wormholes. Can you imagine the possibilities if we could travel the universe like this?
All right, explorers, let's dive into the anatomy of a wormhole. Picture it like this. Imagine a tunnel with two openings. Those openings are called mouths, and they act as the entry and exit points of our wormhole. These mouths could be incredibly far apart, maybe even in different galaxies. Now, connecting the two mouths is a tunnel-like passage called the throat. This is the shortcut that bridges those vast distances in space-time. Think of it like this. If the universe was a giant, wrinkly sheet, a wormhole would be like poking a hole through it, allowing you to travel from one point to another without having to traverse the entire sheet. Of course, we haven't actually observed a wormhole yet, so we can only imagine what the mouths and throat might look like.
We've talked about what wormholes are, but where have you heard about them before? I bet a lot of you are thinking about your favorite science fiction movies, and you'd be right. Wormholes are a staple of science fiction. They've been featured in everything from classic films like 2001, A Space Odyssey, to modern TV series like Stranger Things, which I love, by the way. Wormholes make for such incredible stories because they allow characters to travel vast distances across the universe in the blink of an eye. Imagine zipping from one galaxy to another as easily as hopping on a plane. It's mind-blowing to think about, and that's exactly why science fiction writers love them. But why do we always see these crazy, swirly tunnels when we think of wormholes? Well, it's all about trying to visualize something that's really hard to wrap our heads around. Remember, wormholes are bending space and time, and it's nearly impossible to actually picture that. So, filmmakers and artists often depict them as these colorful, swirling tunnels to give us a visual representation of this complex concept. Of course, real wormholes might look nothing like they do in the movies, but that's part of the fun. Science fiction lets us explore these wild possibilities and imagine what it would be like to travel through these cosmic shortcuts.
So far, wormholes sound pretty awesome, right? A shortcut through space and time? Sign me up. But there's a catch. A pretty big one, actually. According to Einstein's theories, wormholes would need a really special ingredient to stay open and stable. Something called exotic matter. Now, exotic matter isn't your everyday kind of stuff. It doesn't make up the stars, planets, or even your cup of coffee. In fact, it has some pretty unusual properties. For one, it has negative mass, meaning it would actually fall up instead of down. That's totally different from the matter we're used to here on Earth. This exotic matter is important because it would supposedly counteract the intense gravity inside a wormhole. You see, the immense gravitational forces inside a wormhole would want to make it collapse in on itself. That's where exotic matter comes in. Its weird anti-gravity properties could, in theory, hold the wormhole open, acting like a cosmic support beam. But here's the problem. While exotic matter is possible according to our understanding of physics, we have never actually observed it. It exists only in our mathematical equations and theoretical models. Until we find some evidence of exotic matter, the possibility of creating or finding a stable wormhole remains, well, pretty unlikely.
You might be wondering if wormholes are theoretically possible. Shouldn't we have found one by now? We've got powerful telescopes scanning the universe, right? Well, here's the thing. Even though Einstein's theories suggest that wormholes could exist, as of today, we haven't actually found a single one out there in the vastness of space. That doesn't necessarily mean they don't exist, though. Imagine searching for a tiny seashell on a massive beach. The seashell could be there, but finding it would be incredibly difficult. The universe is unbelievably vast, and a wormhole could be incredibly small or hidden in some corner of the cosmos that we haven't explored yet. Plus, even if we did stumble upon a wormhole, it might be really hard to identify. Think about it. A swirling vortex of space-time might not exactly stand out against the already dazzling backdrop of stars and galaxies. We might need entirely new technologies and methods to even detect the faintest signs of a wormhole's presence. So, for now, wormholes remain a fascinating theoretical concept, but who knows? Maybe someday, with advancements in technology and our understanding of the universe, we'll finally unlock the secrets of these cosmic shortcuts. We've talked about wormholes connecting distant places in our universe, but what if they went even further? What if wormholes could be gateways to entirely different universes? This mind-blowing idea stems from the concept of the multiverse, the idea that our universe might be just one of many, each with its own unique laws of physics and maybe even different versions of ourselves. Some scientists believe that wormholes could be the key to traveling between these universes, opening up a whole new world of possibilities. Imagine peeking through a wormhole and seeing a universe where gravity works differently, or time flows in reverse. As wild as it sounds, the possibility of a multiverse connected by wormholes is a tantalizing idea that continues to capture the imaginations of scientists and sci-fi fans alike. Who knows, maybe one day, we'll be able to build our own cosmic shortcut and take a peek into another reality.
So, we've established that wormholes sound amazing. A shortcut through space and time, maybe even to another universe. Sign me up, right? Well, not so fast. There's a pretty big catch with wormholes. They might be incredibly unstable. Think of a tunnel made of sand. It might hold its shape for a little bit, but without something to support it, it's bound to collapse. Wormholes might be similar. According to Einstein's theories, they would need a special kind of matter with negative mass called exotic matter to keep them open. The problem is, we've never actually found exotic matter. It's completely theoretical, and even if it does exist, we have no idea how to get enough of it, let alone how to use it to prop open a wormhole. So while the idea of zipping through a wormhole is super exciting, the reality is that they might be too unstable to be useful, at least with our current understanding of physics.
Hold on to your hats, explorers, because things are about to get really wild. If the concept of wormholes wasn't mind-boggling enough, some scientists believe they could also hold the key to time travel. Remember how wormholes could connect two different points in space-time? Well, since time is part of that equation, some physicists theorize that we might be able to use wormholes to travel through time as well. Imagine stepping into a wormhole and emerging in the distant past or the far future. Of course, time travel comes with its own set of paradoxes and complexities. Could you go back in time and accidentally prevent your own existence? Or what if you traveled to the future and didn't like what you saw? The implications of time travel are enough to make your head spin. While it's still very much in the realm of theoretical physics, the possibility of wormholes as time machines is an incredibly exciting avenue of exploration, sparking countless science fiction stories and pushing the boundaries of our imagination.
Have you ever wondered where the term wormhole came from? It sounds like something straight out of a science fiction novel, right? Well, it turns out we have a physicist to thank for this catchy name. In 1957, the brilliant John Wheeler, known for his work on black holes and quantum physics, gifted us this awesome term. He imagined a worm burrowing through an apple, creating a shortcut between 2 points on the surface. Similarly, a wormhole in space could be a shortcut between 2 distant regions of the universe. Pretty cool, huh? John Wheeler definitely had a knack for making complex scientific concepts more accessible and even a little bit fun. So next time you hear the word wormhole, remember John Wheeler, the physicist who brought this mind-boggling concept to life with a simple yet evocative name.
Now let's dive a little deeper into the science behind wormholes. Remember Einstein's theory of general relativity? It's like the rulebook for how gravity works in our universe. This theory is represented by a set of mind-bending equations called the Einstein field equations. These equations are like complex puzzles, and physicists have been working hard to solve them for over a century. What's fascinating is that wormholes pop up as one of the potential solutions to these equations. It's like the universe is hinting at the possibility of these cosmic shortcuts. However, just because a solution exists on paper doesn't mean it exists in reality. We still need a lot more research and observations to confirm whether wormholes are truly out there in the vast expanse of space and time.
We've talked about how wormholes could be like shortcuts through space and time, but have you ever wondered how big these cosmic tunnels could be? Some scientists believe that wormholes could exist on a microscopic scale much smaller than an atom. These tiny wormholes might be popping in and out of existence all around us, too small for us to even notice. But hold on to your hats, because other scientists theorize that wormholes could be massive, maybe even larger than stars. Imagine a giant cosmic portal big enough for spaceships to travel through. Talk about a shortcut. Whether they're teeny tiny or astronomically large, The potential sizes of wormholes are just another reason why these theoretical objects are so fascinating to think about, don't you think?
Even though wormholes remain theoretical, studying them isn't just about satisfying our curiosity about the universe. It's about pushing the boundaries of what we know and potentially unlocking some of the universe's biggest secrets. Researching wormholes forces us to confront some of the most mind-boggling concepts in physics, like the nature of space and time, gravity, and the very fabric of reality. Who knows what amazing discoveries might be waiting for us on the other side of a wormhole, or even in the quest to understand them? Exploring these complex ideas can lead to breakthroughs in our understanding of the universe, and might even inspire new technologies that could benefit humanity in ways we can't even imagine yet. So, while we haven't punched a hole through space-time just yet, the pursuit of understanding wormholes could unlock a universe of knowledge and possibilities.
Wow, we've journeyed through some pretty amazing facts about wormholes. From bending space-time to potentially traveling faster than the speed of light, wormholes spark our imaginations and make us question the vastness of the universe we live in. Which fact amazed you the most? Let me know in the comments below. I always love hearing from you. Keep exploring, stay curious, and I'll see you in the next video. Bye.